Right, Year 11 homework 2. This is another great homework. Okay, it's quite long, so it's going to take a little bit of time, but if you can get all these right, then higher tier chemistry, you're just going to be laughing at it in the exam because these questions come up all the time. These are all topic 1 questions. Topic 1 questions in Year 10 are common to both Year 10 and 11, so it's absolutely crucial that you're really good at these. First question, how many protons, neutrons, and electrons are there in Na+? Okay. So this is a tricky one, isn't it? Because it's the ion. An ion, if you can't remember, an ion is a charged atom. Okay. So if this question were how many protons, neutrons, and electrons are there in sodium, say, then that would be easier because what you've got to do is go to the periodic table. Okay, here's the periodic table at the back of the book here. Find sodium. There's sodium. It's got a mass number of 23 and an atomic number of 11. So let's write that down here. 2311. Okay. And you'd say, well, the bottom number is the number of protons, because that's the atomic number, then that tells you the number of protons, so 11 protons. Atoms of elements are neutrally charged. Now, protons are positively charged. So if it's got 11 positives, it must have 11 negatives. Which particle is negatively charged? Answer, electrons. And to come up with a mass number, we take the bottom number from the top, 23 minus 11. Now, if that was a bit quick for you, if you go and watch the video of homework 1, I go through this in more depth. Okay, so have a quick read of that. It says 12 neutrons in sodium atoms. Now, this is not the sodium atom, this is the sodium ion. How do atoms become ions? They do this by gaining or losing electrons. Okay, this is by gaining or losing electrons. So let's have a quick look at, say, maybe for the fluoride ion, F minus. If we were doing this for fluorine, F minus, okay, it's got a mass number of 19 and an atomic number of 9. So we'd say 9 protons because protons are in the nucleus. They give the atom its identity. It never changes. That's always 9 protons. So this number down here always tells us the number of protons. Now, protons are positively charged. 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the F minus ion. Okay, now, electrons. If this were the element, there would be 9 electrons, wouldn't there? And every one of these electrons would cancel out one of these protons. However, this is not the element. This is the fluoride, the F minus ion. So this has got an overall negative charge. So how does it get a negative charge? Well, we can't take a proton away because they're locked in the nucleus. There must be an extra electron. So for the fluoride ion, it has 9 protons, but it has 10 electrons. Okay? Now, use the same logic to do this one for electrons, a sodium ion. The protons cannot change because they're locked in the nucleus. We get ions by gaining or losing electrons. To become a negative charge, it had to gain an electron. So to get a positive charge, the electrons are going to be different as well. You have a guess. Neutrons, exactly the same. So 19 minus 9 is 10 neutrons. Okay, if that's for fluoride, you need to do it for sodium. Next one down here. We've got some charges on ions, and we want to use these to come up with a formulae of some ionic compounds. So we're doing sodium hydroxide, sodium sulfate, and sodium nitrate. Well, I'm going to do a different one. I'm going to do an example of a different one. Let's choose, I don't know, magnesium. I'm going to choose, I'm going to choose a different one. I'm going to choose aluminium sulfate. Now, notice in the question, the sodium hasn't been given for you. The charge on the sodium ion hasn't been given for you. Well, the periodic table tells us. Okay, back to the periodic table. If something is in group 1, it's got 1 electron on its outer shell. That means to form an ion, it wants to lose 1 electron. So it's going to form the 1 plus charge. If something is in group 2, it's got 2 electrons on the outer shell. That means to form an ion, it wants to lose 2 electrons, it forms the 2 plus charge. If something's in group 3, it's got 3 electrons on the outer shell, so it wants to lose 3 electrons, so it forms a 3 plus charge. That tells us the number of charge. So aluminium here is in group 3, so that's 3 plus. So to work out the charge on a metal, just look at the group number of the periodic table. Non-metals, group 0, form no charge at all, therefore they don't form ions. They've got full outer shell of electrons. Group 7, they want to gain 1, so they form a 1 negative. Group 6, 2 negative, because they want to gain 2 electrons. You get the idea? The periodic table tells you the number of charges. Right, so aluminium we just discovered was in group 3, so that's going to be Al3+. The sulfate ion is given here, SO4 2-, SO4 2-. Now, in a compound, the number of positive charges have to equal the number of negative charges, and they don't. So the question is here, what do we need more of? We've got 3 positive, 2 negative. We need more negative, so we have to draw a whole nother sulfate ion, SO4 2-. So that's another S, another 4 O's, and those 5 atoms together have a 2 negative charge. So, do we have the same number of positives and negatives? Now we've got 3 positives here, we've got 2 negatives, 4 negatives. They're still not the same. So we've got more negative. We've got 4 negatives, 3 positives. We need more positives. So I need to draw a whole nother aluminium ion. I've now got 6 positives and 4 negatives. So I need more sulfate. So I need to draw a whole nother sulfate ion. So what I've got now is 6 positives and 2, 4, 6 negatives. Now we're balanced. So the formula of that is going to be Al1, 2, Al2, sulfate, 1, 2, 3. How do we write that? SO4. You can't write SO3 because it's SO4. It's SO4, okay, but now we need brackets because we've got more than one of these ions that are made of more than one atom. If we have an ion made of more than one atom and we've got more than one of them, we need brackets. We need 1, 2, 3. There we go. Use that logic to answer all of those. pH of these compounds, well, hydroxide is an alkali, okay? Hydroxides are alkalis. So anything containing the hydroxide ion, the OH- is an alkali. Okay, if it contains the hydrogen ion, it's an acid. Okay, if it's an ionic, if it contains a metal having reacted with a non-metal that maybe isn't the hydroxide or the hydrogen, it's going to be a salt, it's going to be neutral. So these compounds here, these are salts. Okay, so hydroxide alkali, a hydrogen ion is acid. So for example, HCl, hydrochloric acid, sodium hydroxide, NaOH, that's an alkali because it contains a hydroxide. All right, so you just need to have a quick reminder of what the pH is of an acid and what it is of an alkali. Next question. Okay, ionic bonding. These are really hard questions, okay? It's quite a long homework, so don't worry if it's taking you a bit of time. Electronic configurations of magnesium catalyst, so it's not ionic bonding, sorry, it's about reactivity. Draw electronic configurations of magnesium and calcium and use these diagrams to explain which you think is more reactive. Okay, so we did this with the alkali metals. So I'm going to do it with the alkali metals, maybe. Okay, so I'm going to do it with lithium. I'm going to do it with lithium-3, and I'm going to do it with sodium-11. Okay, so dot for the nucleus, 2 electrons on the first shell. That's the electronic configuration, 1 electron here. Next shell, 2 electrons on the first shell, 8 on the second. Okay, 2 and 8 is 10, and 1 more is 11. Right, now, an element is reactive if it can get a full out of shell of electrons really easily. So the question is, which of these can get a full outer shell of electrons more easily? Well, they've both got to lose 1 electron. They've both got to get rid of that electron, haven't they? Yeah? Which can do it more easily? Well, the answer is whichever one holds it weakest. So what's holding that there? What's holding that there? Well, the nucleus is positively charged and the electron is negatively charged. Opposites attract. The nucleus is positively charged, this one's negatively charged. So which one is weaker? Which one is attracted more weakly? The answer, sodium. Sodium is more reactive. Why? Because it's more easy to lose this electron. Why? That electron's further away from the nucleus. Okay? Because there's 1 shell, 2 shells underneath it. Here, there's only 1 shell. Okay? This electron here is closer to the nucleus. So the closer is more strongly attracted, therefore it's less easily lost, therefore it's less reactive. Here, this electron is further away, therefore it's more easily lost, therefore it's more reactive. There's a secondary argument if you want to get really smart. This second shell provides more shielding. So the more shells, the more shielding on this electron means it's more easily lost. But you can stick with the distance argument for GCSE. Draw those out, think about those. Lithium, when exposed to air, reacts with oxygen. Write a balanced symbol equation for this reaction. Well, I'm not going to do lithium, I'm going to do magnesium. Okay? Magnesium is in group 2 of the periodic table. Okay, magnesium is in group 2 of the periodic table. Okay, so it reacts with oxygen to form the 2+ ion, Mg2+. Okay, oxygen is in group 6 of the periodic table. Therefore, it needs to gain 2 electrons to get a full out shell. So it's going to gain 2, it's going to form the O2- ion, O2-. So if we look at those charges, they are balanced. Therefore, the formula of magnesium oxide is MgO. Now, I'm going to tell you right now, when you do that with lithium and oxygen, the charges will not be balanced. So you need to come up with a formula of lithium oxide exactly like we did in this question here. Okay, when magnesium reacts with oxygen, we also need to write the formula of oxygen. If you write O like that, it's wrong and you get the whole question wrong. You never write the formula of oxygen like that, the oxygen molecule like that. The oxygen molecule has the formula O2. Okay, so that gets you 2 marks out of 3 getting these formulae correct. Obviously, I'm not doing your formula. You need to do those yourself. Final thing is balancing. Only balance it when you've got the formulae correct. 1 magnesium there, 1 magnesium there. 2 oxygens there, 1 oxygen there, we need 2 there. You might think the equation is now balanced, but it's not because we've upset the magnesium as well. So we needed 2 magnesiums. Okay, these numbers, these balancing numbers are different for your question. All right, now we've got our ionic bonding diagram. Draw a diagram to show the bonding in lithium oxide. Well, I'm not going to do lithium oxide, I'm going to do magnesium oxide because you can just do lithium on your own. So again, back to the periodic table. Periodic table gives you the atomic numbers. Okay, magnesium has got an atomic number of 12 and oxygen has got an atomic number of 8 over there. Okay, you need to find it for lithium. Okay, so magnesium, dot for the nucleus. Magnesium was 12. Let's write it down there just to remind ourselves. So that's 2 electrons on the first shell, 8 on the second shell. 2 and 8 make 10. So we need 2 on the last shell. That makes 12. Oxygen had an atomic number of 8. So that's 2 electrons on the first shell. And 6 on the second shell makes 8. Okay, now they bond to get a full out shell of electrons. Well, this magnesium is going to lose 2. Okay, it could lose 2 or gain 6. It goes with a lesser number, it loses 2. This oxygen's got 6, so it could lose 6 or gain 2. Well, it's going to gain 2 because that's the lesser number. So what happens? Magnesium gives that electron to the oxygen, and it gives this electron to the oxygen. So I want 2 arrows. Every arrow starts at the electron, finishes at the gap. And label the arrow, please. E- transfer. Now, you do that for 2 reasons. You show whoever is marking it, you know exactly what you're on about. And you also can see exactly where that negative charge is going. The negative charge is coming over here. So this forms the O2- ion. Okay? And the magnesium has lost 2 electrons, lost 2 negative charges, so that's going to be Mg2 positive. Now, little secret for you. After you've drawn this diagram here, okay, for lithium oxide, all right, you should have exactly the same formula as you worked out in this balancing equation. If you haven't, something's gone wrong. Does lithium oxide have a high or low melting point? Well, I'm not doing lithium oxide, I'm doing magnesium oxide. Positive ions, Mg2+, attracts negative ions, O2-. Attract positive ions, Mg2+, attract negative ions, O2-, attract magnesium ions, Mg2+, attract negative ions, O2-. So what we have essentially is a skip full of magnets, is how I often describe it in class. Okay, billions of magnets all attracting each other, really difficult to separate. And that's what we've got here. These ions all attract each other. That magnesium may have given its electrons to that oxygen, but it still attracts other positives and negatives. Okay, opposites attract really strongly, therefore the melting point of magnesium oxide is high melting point. Because to melt it, it's going to take a lot of energy to separate these ions. And that's a lot of heat energy, that's what has high melting point. You do it for lithium oxide, it's the same logic. Okay, is that the last one? No, one more, a couple more. It's long homework, isn't it, to keep going this. Under what circumstances will lithium oxide conduct electricity, and explain? Well, I'll do it for magnesium oxide. Okay, a current of electricity, let's write it down here. A current of electricity is a flow of charged particles. Okay, so you have to ask yourself, can charged particles flow through that? Well, there's 2 charged particles we need to worry about. One is electrons, okay, and the other are ions. So are there any free electrons here? No, there aren't. There's no free electrons. All the electrons are used in bonding. So there's no free electrons, It says no electrons can flow, therefore it won't conduct electricity for that reason. Second question, can ions flow or move? The answer is no, because they're all strongly attracted in the solid state. So, under what circumstances will lithium oxide conduct electricity? So, solid, no. No electrons, no free electrons. And the ions cannot move. However, the liquid state, there's no free electrons because they're still used in bonding. But if these ions, if this is a liquid, these ions are moving, aren't they? Because in a liquid, particles move. So if it's a liquid, those ions could move to oppositely charged electrodes, because you would have a positive electrode and negative electrode, and they would be attracted to those. That process is called electrolysis. Okay, so in liquid, yes, and because the ions can move, you write it out. Last question. Thallium is made of two naturally occurring isotopes, thallium-203, 30%, and thallium-205, 70%. Calculate the relative atomic mass of thallium. Okay, if you haven't learned this formula, percentage times mass plus percentage times mass. Now remember, we need a percentage times mass for each isotope. There's two isotopes here, so we're going to write that twice. We do it in brackets, and then we divide it by 100. If you haven't learned that formula, you're never going to be able to answer this question, and you will always lose 3 marks. If you've learned that formula and you've practiced this, you will always get 3 marks. Chemistry is very honest. Okay, now if that doesn't make sense to you, go back please and watch homework 1 video. Okay, it's just on the other page. Because when we did homework 1, I think I've still got it here because I just recorded it a moment ago. When we did homework 1, I went through a whole worked example about how to do that. The only place you'll go wrong is if you don't work out the brackets first. So 203 is the mass, that goes there. 30% is a percentage, so 30 times 203, press equals, write it out. And then do the same for that one. Press equals and write it out. Then add them together, press equals and divide by 100 and you'll get the right answer. The answer has to be the average of these two. So the answer has to be between 203 and 205. Now there's more 70% is 205, so it needs to be nearer 205. Okay, so it's going to be about 204.5. If you don't get an answer of about 204.5, approximately, that's not exact, I want an exact answer please, okay, it's wrong. Okay, good luck.